last type of mean we're going to look at is the mean of a frequency distribution. Now remember, in a frequency distribution, you've got data organized into classes, and you may or may not actually have the original data set. If you don't, you can use the class midpoint to estimate the mean, and it's pretty accurate. So the mean of a frequency distribution, we're going to say, is x bar, which is found by taking the sum of the midpoint. So I'm going to represent that as x sub m, x with a little subscript of m, times the frequency, and you will divide that by your sample size. So I'm going to indicate here x sub n is the midpoint of the class. This is the frequency distribution we worked with before, which is the out-of-pocket prescription medical expenses in dollars for 30 US adults in a recent year. Estimate the mean expense. So again, we're going to assume at this point I don't have the original data set. All I have is data like this, which if you go searching on the internet, very often you will find the data has been organized for you. We can still calculate the mean with this table. Once again, very often we do this work in tables just because it's a nice way to keep everything organized. So I'm going to go ahead and create a table. If you wonder how I know what headings I want to put on my table, I take my cue from the formula. If I'm able to look up the formula on a formula sheet, it says take the sum of the midpoints times the frequencies. So I create a column for midpoints, a column for frequencies, and a column where I multiply them. Then I total it at the bottom. So to begin with, I find my class midpoints. That's done by taking the lower and the upper class limits, adding them and dividing by 2. So for the first one, I would calculate 155 plus 190 and divide by 2. And that gives me a midpoint of 172.5. I'm going to continue doing that down the rest of the column for each class. I've completed my midpoint column, and I've transferred from the table the corresponding class frequencies. So essentially what I'm doing is letting the class midpoint be a representative value for the class, and I'm going to multiply it by how many times a piece of data showed up in that class. So the last column, I'm going to take 172.5, my midpoint, times its frequency, which is 3, and that gives me 517.5. So to get this first one, again, here's what I multiplied. I'm going to continue going down the table and get the rest of my products. Now that that is complete, the last thing I need is the sum of the frequencies, because that is the n, the number of pieces of data, and I verify that it does equal 30. And I also need the sum of the midpoints times the frequencies, which is found by adding up this last column, and that becomes 8631. So to find my answer, I will now take the sum from the product column, 8631, divide by the 30 pieces of data. This turns out to be 287.70. 2 decimal points here make sense because this is money. So that turns out to be the average expense. Now it turns out if you actually go back to the original data set, which we did have originally, the mean turns out to be 285.5. So yes, you can find the more accurate mean if you have the actual data, but for most purposes, this is close enough. It's within a couple of dollars of the actual correct amount. The last topic in section 2.3 is about the shapes of distributions. The shapes of the distributions that we create using a histogram tells us something about the mean and the median and the mode. So there are 4 different types of shapes that you need to be aware of. which are symmetric, uniform, skewed right, skewed left. Sometimes the last two are referred to as positively skewed and negatively skewed. And the mean is always going to fall in the skew direction. So let's see what that means. If you have a symmetric distribution like this first one, you can see it's got a nice bit of symmetry right around the middle. And the middle is where the mean, median, and mode will all coincide. If your distribution is perfectly symmetrical, those three will be equal. If you have a uniform distribution, uniform is when all of your data has the same frequency. And in this situation, the mode of the data, there isn't any, right? Because in order to have a mode, you have to have something be the most frequent. But here, everything has the same frequency. So therefore, you'll see there's no mode listed, and the mean and the median will coincide. The next distribution is considered skewed left. And the reason it's considered skewed left is the skew direction is always where there is a longer tail to the data. The tail is the side where you get this stretched out tapering effect. You can see it a little bit more easily in the next one. Whichever side the tail is on is the direction of the skew. So the first distribution is considered to be skewed left. And as we saw above, the mean falls in the direction of the skew. So notice the mean ends up being pulled to the left. The average gets pulled down by these low values and will be less than the median, which will be less than the mode. In a skewed right distribution, where the tail is on the right, the mean is going to get stretched to those low values, and the mode and the median will be on the other side of it. So the shape of the distribution gives you some basic information about what you can expect about its mean, median, and mode.